Yeah, I have two questions for Professor von Klitzen. One is, we saw in the table that candela is out of the list that you put. Can we express candela in terms of fundamental constant?
For the chemical industry and for the optical industry, they are very important. They are not so fundamental as the other constants.
So we still have one there that we have to solve, right?
Yeah, because candela is adapted to the sensitivity of the eye, and therefore it's not a fundamental constant in a certain way, the definition, but it's very important for industry. And therefore this is also one of our base units, but it's not as fundamental as the other ones.
Okay, now I have a curiosity that I would like you to explain to us. The von Klitzen constant is the ratio between two constants that's already defined.
Yes, therefore.
So my question is why we need, and I know you know the explanation, to precise point out that the ratio between two constants that's already defined is a new constant that we are defining.
Okay, no, it's not defined. The h over e squared is derived from h and e, okay. But in principle you could also fix h over e squared.
And e is defined now, right?
You could also fix h over e squared and give away Planck constant or elementary charge, but they are established, they are older, and therefore they have the priority. Doesn't matter which one you are fixing, but you can fix off two combinations. In principle, from the scientific point of view, the Josephson constant and the resistance, they are more important for practical applications. So you could fix also these two and throw away Planck constant and elementary charge, but this would be two big changes.
Thank you.
I was very, very interested in your conference, especially in the question of the constants. So what is the relation of relativity and constants? So I know that there are general answers, but for me it's very important to know that we have constants. That to say that they are like columns of the universe. So who put this question? Who put these constants in the nature?
Yes, John, this is something for you. No, there's a very fundamental question whether constants are constant. At the Big Bang, we don't know what are the meaning of constants, and at the expansion of the universe, we expect even changes with time of some constant. But I spoke about the practical application, and for the practical application, we are happy with this, but there are very fundamental additional questions about it. So I think we don't understand really what are the meaning of the constants, and I hope that you will also cover a little bit of this tomorrow.
I wasn't going to. I could say a few comments now. One thing that you hinted at, which I think is amusing, the constants of nature are the things that physicists measure the most accurately out of everything they do, but they're the things that we have absolutely no theoretical idea why they take the values they do. So they sort of combine our greatest ignorance with our greatest knowledge. Back in Einstein's day, he had a vision of he called it a unified field theory, a so-called theory of everything. And he believed that logical consistency alone would uniquely and completely specify the numerical values of all the constants of nature, perhaps bar one. But now nobody thinks like that. String theory and other attempts to find theories of everything have shown that there could be many, many self-consistent theories of the laws and constants of nature. And we perhaps just happen to see a visible universe that is one deal of the value. So there are many logically consistent editions in string theory. So the status of the constants has slightly changed. And if you believe in string theory, with its sort of 10 dimensions, and we live in a three-dimensional subset, as it were, then the true constants of nature that are really constant live in the 10 dimensions. The things that we see are not true constants at all, and they're not necessarily constant. So, but there may be an explanation as to why, they hardly change or they don't change. So I think constants have become a big deal, a big issue again in theory as well as in measurement. I had a question though, what about the gravitation constant in your scheme?
Yes, I mentioned that I'm from the practical side and you cannot measure them. Normally, everyone would say gravitational constant is the best definition for mass because a force between two masses. But the gravitational constant, nobody can measure this accurately, therefore it's not useful for application. And I think if we include the gravitational constant in our set of constants, then we have to give up perhaps the atomic clock. But this is working so well that nobody will replace the atomic clock. So therefore, I think for the future, we will never include also the gravitational constant as a fixed constant for metrology.
But there are so many constants in mathematics, as you know very well, but I'm wondering whether there's any type of relationship that one can derive by a combination of constants in mathematics and constants of nature.
Okay. A whole page of combination of pi and e and all these things to find out the ratio of proton mass to electron mass or some other constant of nature, but nobody believes in it. So I think there's, in my opinion, there's no chance to relate this to mathematical constants. There's many, many publications, also fine structure constant. With very high accuracy, you can find some combination with pi, but I don't believe it.
My question about the new echelon of mass, yes? The Planck constant is known with very high precision. The same precision is the definition of mass, nu.
Yes. Okay, the condition was we used the kilogram in Paris to measure the Planck constant, and the condition was that 3 independent countries should deliver numbers for the Planck constant with an uncertainty of 5 times 10 to minus 8. And last July, there was an agreement in measurements of the Planck constant using the kilogram. And now we're turning the direction, we're fixing the Planck constant, and then everyone has the possibility to realize his own kilogram, and he has not to go to Paris anymore.
And it will be better than old.
No, it is the same. Now it's a transition period. We have the same uncertainty for a balance to compare a kilogram in Paris with another kilogram. But in the future, we have this reference, and we believe that the fundamental constants are more stable than the kilogram in Paris, because we know that the copies and the original prototype, they deviate. There are increasing differences between the masses because some gas is diffusing out of the metal, and they are not stable. So we have an artifact at present which is not stable enough. It's changing about 50 micrograms of 100 years, the kilogram in Paris.
Thank you. But last, in what is destiny the old echelon?
We're still using the platinum-iridium piece of mass in a safe in Sèvres at the Bureau International pour Messier. So this is our official kilogram still. And this weekend there will be this recommendation to change the direction to fix the value of the Planck constant and remove the old kilogram.
Thank you.
This is a question to Dr. Klepner and Dr. Lubchenco, asking them to have a conversation with one another. It seems to me we've had from one of you a plea for thinking hard about how we should conduct ourselves in this world, about the importance and contributions of basic research. We've had a plea for how we should conduct ourselves in this world by pushing science to be more relevant and more engaged with the cutting edge of politics. In the same person, in the same department? If so, what are the promotion criteria, the reward criteria? Can you just talk to each other?
I think Dr. Lubchenco's recipe for talking about science and interacting with the public is admirable. The question is, how does one go about doing it? Now, the reward system in my university doesn't list that, but it recognizes that many places are kind of offended by scientific celebrities. But at MIT, I think we like them. So that's a step in the right direction. But it is difficult to reach out to the public. Probably sitcom is the most effective way to do that. And there was an attempt some years ago, you know, this, what the program, the first 4 minutes, is that the name of it? Yeah. It was a sitcom with a scientific background. It degenerated rather rapidly. I had actually proposed to Leon Letterman a similar situation, but the situation was a bunch of very attractive graduate students living together in a house, and the backgrounds would be these wonderful telescopes and accelerators and all sorts of science. The idea didn't get off the ground, but maybe someone here would like to pursue it.
So, Bill, thank you for the question, and Dan, thank you for your really wonderful, wonderful remarks. I love those examples. Your question sort of implies a dichotomous framing, either or, and unfortunately that's the way a lot of funding decisions are also framed. Do we do this or do we do that? And this, in my view, is absolutely a both and. I am deeply concerned about the loss of funding to basic science. I think it really is a serious threat to our collective future. I also am deeply concerned that we have insufficient attention to what Donald Stokes calls use-inspired science, which in his framing, you know, for those of you who may not be aware of his Pasteur's quadrant, I actually assume most of you have, but he says that basic versus applied science doesn't really describe the world that we're in today, that basic science is curiosity-driven purely with no concept to any practical use. Applied science in his construct is very much taking existing knowledge and using it in a slightly different situation, which is not quite his third box, which is use-inspired science, making fundamental advances, but driven by immediate problems or the need to solve immediate problems. And a lot of what I was describing is in this category of use-inspired science. And we have neither sufficient funding for basic science nor for use-inspired science. And I think that is a common challenge, especially in this post-truth world, where neither of those is valued. And so I think your question, Bill, is partly, well, I was actually going to ask a question, which was, how do we promote and sell the importance of both of those in a world where facts don't matter to everyone, where opinions carry more weight than evidence? I think that is a fundamental challenge, and in my view, until more people, not only in the United States, but around the world, understand how science has benefited them, and how we got, you know, people aren't going to sit down and listen to the wonderful examples you gave, but we need them to appreciate how important it is. So that is a challenge, and part of it, it's not just the reward system in academia, it's also scientists, or the common people's perception of science. You know, some of the polling that has been done suggests that most Americans, at least, cannot name a living scientist. Or over 70% of Americans cannot name a living scientist. So that is, maybe that speaks to the importance of celebrity. You know, the few that they do name, Neil deGrasse Tyson, Stephen Hawking, when he was alive, are among those. But I think we have a real challenge, and I think that something that concerns all of us, and it's partly our reward system, but it's how we communicate the importance of science much more broadly. Those are all intertwined, and I don't have the answers, but I'm concerned about it.
Just to continue on that, and it's just a comment on Dr. Klepner's talk and what Jane just told us. It's the internal balance between the moral right of the society to set its priorities, and I'm not talking about translational or applied versus basic, to set its priority versus the freedom that we as scientists think we should kind of fly on. You just talked about development of biodegradable plastic. That's something, an unmet need, versus, for example, the investment in a 30 meters telescope. Or we talked about neurodegenerative diseases investment versus understanding the brain connectome. So I think that the society should have, and again, I don't have a solution like you don't, of the internal balance between basic science that may be applied very long term down the road versus unmet needs that need solution. Not now, but we are all facing practical problems between Alzheimer to contamination and of the ocean and extinction of species in the ocean and so on and so forth. So this balance must be discussed somehow. This society has some priority over investment of its own taxpayers' money. And again, it's nothing to do with applied and translational, because development of biodegradable plastic, it's a basic fundamental research question.
When I gave the conditions for science to flourish, the first one was a society where knowledge is appreciated. We don't really have that. It's not on the top of our list. We are a very secular society, and the first approximation, wealth is appreciated. How do you change the cultural atmosphere of a society?
Unfortunately,
you'll have to answer that.
It goes backward not only in your country.
Yeah.
In many countries worldwide.
We set a very bad example for our friends to follow.
I'm speaking as someone who's done outreach in Europe, in Africa, and the United States. And one thing I've noticed is there are some sciences that are more appealing to the general public than others, astronomy being one of them. I think one of the joys of astronomy is that it is pure research that no one can get rich from, except Neil deGrasse Tyson. And as a result, it doesn't carry a political weight. 10 years ago, I was the chair of the Division of Planetary Sciences of the American Astronomical Society, and one of our jobs was to go to the US Congress looking for money. And we discovered that it was one of the few things that did not have a Republican versus Democrat weight. There are people on both parties who thought space science was wonderful, and people in both parties who thought it was a waste. But it certainly was not along the usual split. That's one of the benefits of it. The place where I find astronomy being very popular is in the social networks, and it's often young scientists who are very well versed in social networking who are astronomers, who are leading the way. And generally, I find it's mostly women in their 30s and early 40s who are doing a lot of this. There's a researcher who works in the atmosphere of Titan at Johns Hopkins University, Sarah Hurst, who probably none of you have ever heard of. But she has 47,000 followers for her Twitter account. I do think that those of us in a science that is easily understood really need to take on the role of being the leading wedge to remind people that science is fun, science is exciting, and it's something that can reach across and get people excited even when they don't see a monetary advantage to it. So I think that's one of the advantages of some kinds of pure research.
I think it's, it's a very multiple-sided question, and one of the things that really impressed me is Tony Leiserowitz at Yale, who puts out sendings on people's belief or acceptance of global warming as a problem. His mailing or his email web that really astonished me is when you look at those who, and global warming has gained in acceptance, climate change in the United States. The thing that really surprised me was he then census people on both sides of the question, and in general, neither one of them had any reasons for their belief except someone outspoken whom they believed in had said something about it. That would imply several things. We have to be very good about getting scientists to speak out and speak out to the public. Biodiversity's been a very subtle subject, but Richard Attenborough, for example, has had to have had a huge influence on people's understanding of biodiversity and why it's important to us. On the other hand, I think we have to encourage very, very good science education in all our schools everywhere. And I think we have to accept the fact that people do gravitate in their busy lives to authority figures and try to encourage good, dependable authority figures to get out there and do something about it.
So looking at the clock, I think this is a good moment to conclude today's session. I want to thank our speakers and all of you for lively discussions.